Now, what we're going to do is inverse trig. The fun, oh my gosh. All right. Now, in your books, you might want to open it up. It'll be a little bit easier probably if you're looking on page 45. Okay? Page 45. Now, first of all, with your hands, show me what does the sine graph look like? Doesn't it go like this? What about cosine? It also goes what? Like that, doesn't it? How, okay, for me to talk about inverse sine and inverse cosine should already bother you. Why? They're not what? They're not one-to-one. So how are they going to talk about inverse sine if sine's not one-to-one? They're going to do what they did a second ago. They're going to chop the graph off. Now, let me show you 1,000 years ago how I learned to graph, which has been very helpful in my life. Okay. Even with a grapher, sometimes this is just faster. And it has lots of things the grapher doesn't. We'll go back to that unit circle that was on the board a second ago. I erased it too fast. Now, I'm going to do y equals sine x. Now, does sine depend on x or y? Y. All right. This is 0 degrees right here, isn't it? What's your y coordinate? It is 0. So what's the sine of 0? 0. That's 90 degrees, isn't it? So look on your unit circle, it's 90 degrees right there. So what's the sine of 90 degrees? What's the sine of pi over 2? Is it 1? So what, pi over 2? Your sine is 1. All right. What's the sine of pi? Isn't pi right there? Tell me it depends on y, so what's my y coordinate right there? 0. 270, so 3 pi over 2. What's your sine? What's your y coordinate? 3 pi over 2. -1. What about when you're back around to 360 or 2 pi? What's your y coordinate again? 0. And we can just keep going, right? Back around and around. Now, these are negative, so let's go negative. Negative's clockwise, right? So a negative 90 degrees. What's your sine? What's your y value there? -1. So at negative 90, I'm back down to a -1. If I go to a negative pi, what's your sine? Is it 0? All right. If I go to a negative 3 pi over 2, go right there. What's my sign? Isn't it 1? And if I go to a negative 2 pi or a negative 360, I'm back in 0. So this is your sine curve. If you're graphing it with your grapher or by hand. So we agree that's not 1-to-1, correct? Now, here's the catch. On the inverses, they're going to chop the graph off. On the original graph of the trig function, you've got 2 possibilities. They're either going to use 0 to pi, or they're going to use negative pi over 2 to pi over 2. So 0 to 180 degrees, or negative 90 degrees to what? 90 degrees. Now, look at this curve. If you chopped it off between 0 and pi and just kept the part of the graph between my hands, would that be 1-to-1? No. All right, what's your other option? Negative 90 to what? To positive 90. Is the graph between my 2 hands there 1-to-1? Do you see it, Pamela? So from here to here, there to there, is that 1 to 1? Yes. So 0 to pi is going to be the inverse. We're going to use the inverse of which ones? I mean, of what? I can't write. Sine. Is everybody okay? Now, which one follows sine? What's its reciprocal? Cosecant. So if sine is going to be from 0 to pi, what else is going to be from 0 to pi? Cosecant. Now, I'm going to erase this for a second. Instead of doing sine, let's go do cosine. All right. Y equals cosine of x. All right, go back to your unit circles. Cosine x or y? It's x. So at 0, what's your x coordinate? 1. Not 0. Before it was 0, now it's 1. What about at 90? At 90, what's your x coordinate going to be? That's going to be 0, isn't it? What about at pi? What's your x coordinate? -1, isn't it? What about at 3 pi over 2? What's your x coordinate going to be? I think it's hard to see that. I'll make sure Kelsey can see it. All right, at 3 pi over 2, do you understand your x coordinate's back to what? 0. And at 2 pi, you're back to a what again? 1. All right, go in the negative direction. All right. If you go to a -90, what's your x coordinate? 0. If I go to a negative pi, my x coordinate's a negative what? 1. When I go around a negative 270 degrees, my x coordinate's back to a 0. And when I go to 2 pi, now what am I back to? A 1. There's your cosine curve. Now, I got to chop it off because it's not 1 to 1, right? Now, last time we chopped it off between what? I'm sorry, I wrote this down backwards. We're not supposed to be here.
Yeah.
When I make a mistake, y'all need to tell me. All right. Because I don't want y'all to write it down wrong. Okay. Now, if I chop it off between negative pi over 2 and pi over 2 like I did last time, is that going to work for cosine?
No.
No. So what's my other choice? 0 to what? Pi. So this time, I'm going to have to put cosine up here. Now, if cosine's up here, what's going to follow cosine? Secant. Okay? Now, let's do tangent. Okay, y equals tangent. Now, what is tangent in words like sine and cosine? Tangent's what?
Sine over cosine.
Sine over cosine. So when are you going to be in trouble on this graph? When cosine's what?
0.
0. Do you understand that? Because if cosine's 0, I'm 0 on the bottom of the fraction. So it's going to be undefined when I have 0 on the bottom. Now, is cosine x or y? X. All right, look over here and find when your x's are 0. All right, where is that 0 at what?
Over 2.
Then I'm going to have an asymptote right there. Where else am I going to be in trouble?
3 pi over 2.
At 3 pi over 2, so I'm have another what?
Asymptote.
Asymptote. Now go in the negative direction. Would you have another trouble at negative pi over 2?
Yes.
And at negative 3 pi over 2. Now in tangent, sine over cosine or y over x. So in 0 degrees, what's 0 divided by 1? Isn't it 0? Now, do you know what the sine and cosine? Do you know what the sine of 45 degrees is? It's 1. So at 45, I'm going to be way up here, and at negative 45, I'm going to be down here. So these are the ones that do the little S curves. Everybody with me? Now, here's what's fun about this one. Do you see between negative pi over 2 and pi over 2? Is that 1 to 1?
Yes.
What about between 0 and pi?
Yes.
It'd still be 1 to 1, right? So if I chopped it off between 0 and pi, I'd have this part and that part. Everybody with me? From here to here, I'd have that bottom half and that top half. That'd be 1 to 1 too. So they could have chopped, they could have either gone negative pi over 2, pi over 2, or 0 to pi. They chose negative pi over 2 to pi over 2 so they wouldn't have to jump over an asymptote. So they're going to go with tangent down here. And they're going to go with cotangent up here. Now, here's what you're going to have to memorize or figure out. I don't care. There are 2 ways for them to write inverse sign. Sometimes they'll write it like this. But most of the time in your book, they're going to put it like this, arc sign. Arc sign means the inverse of what? Sign. Arc tangent is going to be the inverse of tangents. Everybody with me? Now, I want you to think a minute about a graph. Do you understand that 0 to pi would mean you would start here and go over to here? Everybody okay? What quadrants is that? 1 and 2. So any answer to arc cosine or arc cotangent or arc secant is going to have to be a quadrant 1 angle or a quadrant 2 angle. Now, where does negative 90 to 90? All right, does negative 90 right here? So negative 90 to 90 is going to be what 2 quadrants? 1 and what? 4. But you got to be careful. Because if you're in quadrant 4, you can't say something's like 300 degrees. You have to say a negative 60. Because a negative 300 wouldn't be between negative 90 and what? 90 on the number lines. Everybody with me? Now, why are we saying all this? You're going to have to memorize. Which quadrant's missing? 3. 3 is never an option when it's inverse. Now, these are going to look almost exactly like the same problem, but they're not the same problem. Both of these are asking you when the cosine of an angle is negative 1/2, what is the angle? Because I want you to stop and think. Remember what inverses do to each other. What happens to the domain and range? They get what? They get switched. So on regular trig, aren't you putting in the angle and getting out the real number? So with the inverse, they would put in the real number and get out the angle. Now, these are the ones you had for homework for today. This is the one you're gonna have homework for next time. Now, the answers are almost the same, except this one has fewer answers than this one has. So let's go do this one real quick. And I would tell you on a problem like this that theta is probably between 0 and 2 pi, so you don't have an infinite number of answers. Now, your angle, the cosine of your angle is a negative 1/2. Does cosine depend on x or y? X. In which quadrants is x negative? So I'm going to have a quadrant 2 answer and a quadrant what? 3 answer. Over here, as soon as I see arc cosine, I'm going to have one answer. Now, which ones are between 0 and pi? Arc what? Cosine. Arc what? Secant. And arc what? Cotangent. Which ones are going to be between negative 90 and 90? Quadrants 1 and 4. That's going to be arc what? Sine. Arc what? Cosecant. And arc what? Tangent. Now, you can straight up memorize them. Now, this is the way I used to keep it straight 1,000 years ago, the first time I learned it. What they're really doing is giving you a positive quadrant and a negative quadrant. Arc cosine has to be quadrants 1 and 2. Because doesn't cosine depend on x? And see, x is positive here and what? Negative there. If you put arc cosine under this, you'd have a positive and another what? Positive, because x is positive in both. So they're giving you a positive quadrant and a what? Negative quadrant. Now, if I knew cosine, I knew secant, because secant follows cosine. If I know sine, I know cosecant, because the reciprocal follows the original. Is everybody with me? Now, here's just my memory trick. Because on 2, that's negative for cotangent, but so is what? So is 4. It goes with the numerator. What's your numerator on tangent? Sine or cosine? Follows sine. What's your numerator on cotangent? So it follows what? Cosine. So here's what I know. As soon as I see arc, now it doesn't say arc over here. As soon as I see arc, I write down what 2 quadrants is defined in. So is cosine defined in 1 and 2 or 1 and 4? 1 and 2. Now, is this number positive or negative? Negative. Then which quadrant have I got to be in, 1 or 2? 2. There's a quadrant 2 answer on. So this one's going to have a quadrant 2 answer and a quadrant 3 answer, but this one's only got a quadrant what? 2 answer. Now the way I get them is the same. I build the triangle. What is cosine in words? Like adjacent, opposite, and hypotenuse. Adjacent over hypotenuse. So that must be my adjacent, and that must be my hypotenuse. So my adjacent side is a 1, my hypotenuse is 2. So what's that missing side going to have to be? Square root of 3. So what angle measures that? 60. 60. So my reference angle is 60 degrees or pi over what? 3. We okay? Now, I don't put 60 degrees down or pi over 3 because I need a quadrant 2 and a what? Quadrant 3. So in quadrant 2, I'm supposed to know that my reference angle is 180 degrees minus my given angle. My reference angle is 60. So what do you subtract from 180 to get 60? What? 120. So my answer is 120. All right. All right. So my angle's 120. Now that's got to be something times your reference angle of 60. What do you multiply 60 by to get 120? 2. Well, what is 60 really? It's pi over what? Isn't it pi over 3? So what's my quadrant 2 answer? 2 pi over 3. Now I need my quadrant what? 3 answer. Well, in quadrant 3, your reference angle is your given angle minus 180. My reference angle we agreed was 60. What do you subtract 180 from to get 60? 240. Well, again, 240's got to be something times your reference angle. So what do you multiply 60 by to get 240? 4. What is 60 in terms of radians? Pi over what? 3. So what's my quadrant 3 answer? What's the answer to the arc cosine of a negative 1/2? It is only what? 2 pi over 3. You can't give them the quadrant 3 answer because it's not defined in quadrant 3. Arc cosine is only defined in quadrants what? 1 and 2. Arc sine is only defined in quadrants what? 1 and 4. So it's the same question with restriction. Now, let me show you one more, and this is the one that bothers people the most, but it's actually the easiest. Arc sine of a negative square root of 3 maybe over 2 versus the sine of theta is a negative square root of 3. Does that depend on x or y? Y. All right. Where is y negative? What quadrants? 4 and 3, correct? So this would have a quadrant 3 answer and a quadrant what? 4 answer. Now I did this one on purpose just because I've already got it drawn. All right. What is sine in words like adjacent, opposite, and hypotenuse? Opposite over hypotenuse. Okay. So when you build your triangle, your opposite side is going to be the square root of 3. Your hypotenuse is going to be 2, and the missing side is going to be a 1. So see, I'm back to what? Because I already had it drawn. All right. So my quadrant 1 answer is 60 degrees again, or what? Pi over what? 3. But I don't need quadrant 1. I need quadrants what? 3 and what? 4. Now a minute ago, didn't we find quadrant 3 on the one we just did? What was the quadrant 3 answer? Wasn't it 4 pi over 3? Well, let's go get the quadrant 4 answer. Well, in quadrant 4, your reference angle is 360 degrees minus your given angle. Now remember what my reference angle is. My reference angle is what? 60. What do you subtract from 360 to get 60? 300. 300. All right, well 300 is something times 60, right? What do you multiply 60 by? 5. The 5? Well, 60 though is what? Pi over 3. So we get 5 pi over 3. Is everybody okay? Now, arc sine is defined in 2 quadrants. It's either 1 and 2 or 1 and what? 4. 3 is never an option when it says arc. So is it 1 and 2 or is it 1 and 4? It's 1 and 4. Now, one of those is a positive quadrant and one of those is a negative quadrant, right? The sign depends on X or Y. Y. Which one is Y negative in 1 or 4? 4. So this is only going to have a quadrant what? 4 answer. Not a quadrant 3 and 4. Everybody tracking with me so far? Now here's the part that I'm not happy about, but I didn't do it, so don't blame me. What do you think I'm going to write down here for my answer? 5 pi over 3. But that's not right. Because of the way they defined it. Because a negative 90, you see what I'm saying? In other words, this is 300 degrees. But 300 degrees is not between a negative 90 and a what? A 90. So the lovely thing to me about these, when they're arc, if it's quadrant 4, it's just a negative in front of your reference angle. That's way easier than going and getting all this. Is everybody with me? So it look, you'd think it'd be 5 pi over 3, but it's just a negative what? Pi over 3. If it's written arc, if it's written this way, you cannot put negative pi over 3. Why? Because remember my directions on these kind of problems said theta is between 0 and 2 pi. I don't give you permission to have negative values. So you got to follow the direction. So it's not any different than what you had for homework from last night, really. They're giving you the answer, and you're giving them what? The angle. Okay? It's just when it's got arc in front of it, you're restricted to 2 quadrants. One's positive and one's what? Negative. Now, do you understand if it had said arc sine square root of 3 over 2? As soon as I see arc, I think it's either 1 and 2 or 1 and what? 4. All right, is arc sine 1 and 2 or 1 and 4? 1 and what again? 4. Isn't that positive? So this would have a quadrant what answer? It's a quadrant what answer? Okay, so it's really not anything new. It's the same thing you were doing with a restriction. But if you don't know which quadrant you're allowed to be in, then you're kind of nailed a bit. Which one is never right? 3. 3. 3's out. Well, look what would happen if you got confused on, say, this one, and you said quadrants 1 and 2. You should catch your own mistake, because doesn't sign depend on y? And what's the problem right here? Y is not negative what? In either of those. Oh, it should have been 1 and what? 4. So you should be able to catch your own mistake if you understand kind of what I'm talking about. Okay? So part of your homework is going to kind of be doing that. All right? Now, the other thing I'm going to take 5 whole minutes, all right, to talk about. We're going to do way more of it next time. Okay? And that is this. What I have found out, here's what I kind of need you to do real quick. You're way more familiar with this one than you are with this one. Right? What's that one graph? Gravel. I wish I could graphers and just graph this one for me. Y equals 2 to the x. See what the picture looks like. Got it? What's 2 to the 0 the same thing as 1, right? So does your graph look like that on your graph? All right, graph this one for me. Y equals 3 to the x. All right, what's 3 to the 0? So they have this point in common, don't they? But the difference is, this one's a little steeper right there and a little lower down here. Is everybody with me? So this is kind of y equals 3 to the x, and the red one's y equals 2 to the x. You know what pi is, right? What's pi approximately? 3.14. Well, there's another irrational number called e. Do you know what e is approximately equal to? 2.71. So if I told you to graph y equals e to the x, do you understand that e is just a number? And it's a number between 2 and what? 3. It's a little closer to what?
3.
To 3. So it's going to be a little closer to the blue graph. So that orange graph is just y equals e to the x. That's all it is. There's nothing hard about it, magical about it. It looks just like that. Now, they're going to ask you questions about this graph. They're going to ask you things like, what's the domain? Okay, look at that orange graph. Is domain x's or y's? Do you have points when the x's are negative? Like, aren't these your negative x's? Have you got points there? Yeah. Does it work when x is 0? Is there a point when x is 0? What about positives? So what's my domain going to be on this one? All real numbers. Well, tell me something you notice about the range, the y value. They're never negative, are they? Do they even touch the x-axis? Are they ever 0?
No.
So my range is going to be parenthesis or bracket at my 0? Parenthesis. All right. Does this thing have an x-intercept? Does it? No. Does it have a y-intercept?
Yes.
Yeah. What's the y-intercept? 0 what?
1.
Now, is this thing 1 to 1?
Yes.
Yeah. Well, now if it's 1 to 1, what's that mean it's going to have? Have an inverse. Which we're going to talk about next time. But now you already know some things about it on the inverse. What's the domain of this inverse going to be? 0 to infinity. What's the range of that inverse going to be? All real numbers. Is this inverse going to have a y-intercept? No. What's it going to have? An x-intercept. What's the x-intercept going to be?
1, 0.
And if this one's 1 to 1, what's this inverse also going to be?
1, 1.
Now, where's your homework going to be?
Middle.
Middle. Now, what I would do if it were me, I'd go back through that trig review and algebra review and try to see if you understand what I wrote. Does that make sense? If you cannot still work it right, you need to make an appointment and come see me. You don't have to be right away. It'll be next week. Is everybody with me? But, you know, sometimes you're like, oh my gosh, I see I made a careless error. That's different, man. I really couldn't work one like this on my first test. All right? And you don't ever need to walk in a test going, I hope she doesn't ask wrong. Okay? Because if you're like mine, that's the first thing I'll ask. All right? So we're not going to gamble with our grades. So if you need some help, come see me. Okay? And I will see y'all on Wednesday.